so I'm going to go on based on the assumption that most of you are kind of curious. You kind of know a little bit about what cloud computing is, but for the most part, it's going to be pretty high level. So I think a couple of questions actually came up so far during Oceanhackweek, and I've listed them here. The specific topics that people are really interested in are data storage. How do I get my data onto the cloud? Oh, sorry. Is that big enough? Okay, great. And then also there were questions about security and private data. I think there is some confusion about what open source really means, whether or not the cloud is actually secure. If I have a contract from the DoD, what should I be doing in terms of thinking about cloud computing? And then the other thing I think is good to demystify is what exactly is Pangea? I know that you've been using that for the last 2 days, but really, if you look at it, the interface is a Jupyter Lab interface, which a lot of you are familiar with. So what does the Pangea project or the Pangea platform actually add to this experience? So let's back up a little bit and try to understand exactly what cloud computing is. I think on the first day we saw a slide that talked about, oh, how Google Drive and Netflix, they're all on the cloud. They are on the cloud, but for research, what we are concerned about in terms of cloud computing is really the compute and the storage. I like to use the analogy. How many of you actually heard this analogy, cattle not pets? Okay, so back in the day, we would have servers, right, that sat under your table, and you would give it a name, and you would have a system administrator that managed it. They would install updates, they would install like Ubuntu on it, and they would call it, a really fancy name like Jupyter or I don't know, Oracle or something, right? And you would baby it, and time would come, and you would patch it, and you would upgrade the disks, and then when it died, all your data died with it. Everyone was really sad. They would just cry over it. They'd be like, "Oh my God, my computer's dead. Now I have to go find more money and build another new computer from scratch." But the cloud kind of takes away that aspect of it. Instead of having a pet, right, like a pet named Jupyter, you just have a bunch of cattle. You have a bunch of computers sitting there. They're disposable. If one of them died, like a cow, you would just take them, not died, if it was sick, right? It was sick. You would take them out back. You would, do something, and it would cease to exist. But then you would have 100 other cows in its place, right? So I like the analogy of cattle, not pets. If you think about cloud computing, is that you have this massive scale of computers, and you never really have to baby them. Okay. So, and then the other reason about thinking about why you should be moving your research to the cloud is that more and more of these data sets, the data sets that you care about. So for me, I do a lot of geosciences. I care about Landsat moving to the cloud. I care about Sentinel moving to the cloud, right? And you really want to think about, scientists tend to like to hoard things. They like to hoard computers, they like to hoard data, they like to replicate data. They're like, well, if it's living on my computer, it's mine. Trying to change that mindset of moving your compute to where the data is stored would actually be a more efficient process. And this is a, does anyone know where this is from? Alice in Wonderland. It's the Red Queen. And a lot of times researchers are kind of like, that image where you're running in place, you're doing the same thing over and over again. And it's really just opening up your mind to trying something different. And so there are actually about 6 advantages, maybe more, maybe less, on using the cloud. So actually, I think one of the good things to clarify, and I think Valentina brought this up, was that there's this notion of what exactly is the public cloud? Is Amazon or Azure or Google Cloud really public? Well, I think the better terminology for public cloud is the commercial cloud, so that you don't actually get confused between what's private and what's public. And advantages of moving to the cloud as one of the research platforms is that you really don't have to wait for computational tasks to start. So if you're used to using things like a traditional HPC system, right? If you are used to using, for example, Cheyenne and Car supercomputer, you know that it takes you time. You have to get on the queue, you have to wait. Even like getting started on it, getting an account takes you forever. Whereas with the public cloud, you really just jump on, for example, if you use Amazon Web Services, you jump on a console, you can provision lots and lots and lots of computers at your fingertips. And you really don't need to purchase and maintain any of this hardware. It's all maintained for you, obviously built into the cost by these commercial cloud vendors. And you really don't have to think about even building a cluster of your own, because you can actually just do that on the cloud. And so this is really number 4 ties into the whole scalability thing. And then number 3, I'm jumping by numbers. But anyway, number 3 is you pay as you go. So, when you write grants, traditionally, when you wanted to build your own computers, your own clusters, you would write in a grant, like, I need $3,000 for building a computer with crazy amount of RAM and a GPU or whatever. But on the cloud, you have to kind of rethink about this pay-as-you-go method, right? You only pay if you use some of the services. And also the reason to think about moving to the cloud is that there is an expanding community. So just like Ryan mentioned on Monday, that there's a lot of people that's behind this open source community. And again, they just keep making new stuff. If you log on to AWS and you go through the list of services that they offer, right? You get machine learning services, you get database services, you get all these things. They're trying to abstract things more and more. And so the cloud community, because you're commercial, are building so many new things that you can always find something that's right there that caters to your own research needs. So, but then there are reasons to not migrate to the cloud. Despite what anyone says, the cloud doesn't solve all your problems. So if you have a pipeline, or you have an architecture, or you have a computing solution that works for you, stick with it. Because there is a huge learning curve when you do decide to go to the cloud. It is not as easy as many people will tell you. You actually have to think about different ways of sometimes even involving writing new code just to get it to work on the cloud architecture. And so here are some bullet points, and this is actually just on the web. You can see the link right here, the URL right here. You can follow along with this, and I'm just going to go through it really quickly. And also, so 1 and 2, I've talked about that. And then also the third thing is that if you actually use your computers a lot, if your computer is always on, so Ryan mentioned that, if you don't use Pangea, your server is not running, please shut it down. So because every minute that server, that a computer is running in the cloud, it's costing you money. And if you're not actually doing anything on it, then you're just wasting your money, right? But if you are actually one of those people that do deep learning and you have to have a computer on at all times, then you might want to rethink whether or not the cloud is actually the most cost-effective solution for you. And also, earlier we had questions about, well, I want to work with private data, I want to work with DoD data. So if you, for example, are a medical researcher, which I guess none of you are, but you'll be familiar with things like patient privacy, about HIPAA compliance or FERPA compliance. Those are things that are administratively going to really inhibit you from using the cloud effectively. There are obviously solutions around those things, but if those are starting to get like really in the way, then you might want to rethink whether or not cloud is the best solution for you. So what I really want to point out here is that all these are on the web, but I want to go back to this 3 key points that are pertinent to what we are going to learn here this week. The first thing that, maybe I'll go from 3 to 1. So talking about demystifying what exactly Pangea is. Just a show of hands, who are anyone still kind of iffy, particularly on what Pangea is, or why we have a Jupyter Lab interface, but then we talk about all this, you know, how I'm getting data on it, and just trying to get a sense of like what kinds of questions you may have about the Pangea platform. Yes. That is a very good question. So let me just high level overview of what exactly Pangea is. So Pangea is essentially a glorified Jupyter Hub. So if you work with Jupyter Notebooks, a Jupyter Hub is a server that deals out Jupyter Notebooks based on users, right? So every time you log on to Pangea.io, it's saying, okay, create a new Jupyter Notebook pod for me. So Pangea is built on Google Cloud with credits given to them to the Pangea project by Google Cloud. They have also built Pangea on AWS with credits that were given to them by Amazon Web Services. And I don't know if Tim is here, but Tim has also gotten a grant to build Pangea on Azure. So right now, the model that they are going for is to hopefully have the cloud providers adopt Pangea as a large-scale computing platform. Sustainability-wise, you can actually install Pangea anywhere. You can install Pangea on Exceed. You can, I think Cheyenne actually has a version of Pangea up. And long-term, I think they're looking to the cloud providers to actually take Pangea on as a computing solution. And then it comes back to, so like I said, Pangea is really a glorified Jupyter Hub in the sense that the underlying infrastructure are things that we're all familiar with. It's built on top of Dask to farm out those little works to workers. And they're using the scalability of cloud, right? So if you're farming out all those little works, little jobs on the cloud, you can actually spin up as many worker nodes, which is what Ryan was talking about when he talks about worker nodes, is replicas of those computers that can do those jobs. And on the cloud, you basically have infinite amount, almost near infinite amount of those computers that you can use. So that's why Pangea is such a great platform for the cloud, because it's utilizing all these great computing power from the cloud. And going back to the data storage issue. So if you can actually upload your data to the cloud, then you can access it from Pangea. You can access it from anywhere. And Tim had mentioned before something about Xray, right? Xray is really a cloud optimized format. So what cloud optimized means is that it works best when your data is in the cloud, where you're doing all the processing in the cloud. My sense is that if you are not using the cloud, there's really no need to learn about things like Xray. You can stick with NetCDF, that is fine. But again, what we are trying to do is to change the mentality, because a lot of like I said, a lot of the data sets are actually moving to the cloud. You're working with larger and larger amounts of data, and it's really just important for you to make use of the computing powers that are out there. So I wanted to actually walk through a hands-on demo. I'm not actually, you don't have to follow along. Hands-on demo of how to get a data set. For example, I'm going to use a CMIP6 data set, a NetCDF, from an OpenDAP URL to your computer, and then process it in a way that you can upload to a cloud data storage. So we actually have cloud data storage solutions open for you if you're interested in using them for your own projects this week. Please, this is just an example of how you would utilize that data storage. And also, the other thing to point out is that there are different data storage solutions on the cloud. So for one, that you would probably hear a lot of times is something called object storage. And object storage, so if you are familiar with the term S3 buckets, you've heard that, that's an object storage. On Google Cloud, it's Google Cloud Storage, that's an object storage. On Azure, they call it a blob, which I think is more apt. It's just a blob. It's like, so is everyone familiar with what object storage is versus file storage? Okay, so when you, in object storage, you don't actually have a file system. The file system is an illusion. So file systems are folders and then files listed underneath it. If you log on to a, for example, I'm going to pull this up right here, right? This is Google Cloud Platform. This is the name of a bucket that I've created called OHW example. And if you click on it, you'll see that I have files here, and you will see that I also have a folder. So the question then becomes, well, I'm seeing all these folders. What are you talking about, object storage versus file storage? Because I can see all these folders right here. But the way that objects are read, object stores are read, is that they don't read them in little bits or little chunks like files. They read the entire thing. So when you read or write an object, it stores everything in a giant chunk with little metadata attached to it. So you can't actually go in to an object and try to take out little bits and pieces like you could a file, right? But that gives a really great benefit to object store is that you can just then, if everything is stored in metadata and stored in giant little chunks, then you can have nearly an infinite amount of storage. So that's why object store is used a lot of times when you're just storing data, but not actively reading that data. And so ZAR is one method of, yes?
Sorry, I didn't quite follow what they're about, that when you have near infinite storage.
It's because you don't have to, there's none of those that added, how do I say it? That added layer of having to do a lot of processing when you read and write. So everything is just like metadata. So it's like really compressed, and it's like object blobs, I like to call it. So it's like little blobs that you can't actually go in and like do stuff to. So it just makes it more efficient, right? Okay. All right, where was I? ZAR, yes, sorry. Okay, so ZAR. So I was looking at this bucket. Okay, I'm going to go back to the Jupyter Lab, and then we're going to talk about a little bit about how you would actually work with real data, okay? I am going to show you, and this is something you don't follow along. This is actually the Searing Up 6 website. And I'm going to go and look at some files, right? So let's say I wanted to work with a netcdf file that's here, and I wanted to look at land surface data. I wanted to look at surface temperature. I would go in and I would look around for this, and I said, okay, I have the OpenDAP URL. So right here in Jupyter Lab, and this is on Pangea. Okay, this is basically I logged into ocean.pangea.io and I created a new notebook. So I am actually going to import Xray. Okay. And I'm going to also import something called GCSFS, which is Google Cloud Storage File System. So if you remember that I said that Google Cloud Storage is an object store, what we want to try to do is try to actually use Google Cloud Storage as a file system. So this is what this Python package actually does, is it mounts your Google Cloud Storage as a file system. So it actually lets you do a lot of things that you can do with a file system. And then the other thing that we want to do is, actually I'm gonna cheat a little bit. I actually have a whole bunch of stuff here. Is also import this package here. All right, and I'm gonna run that. And then I'm gonna say, okay, xr.open, oh yeah, sorry, okay, xr.open dataset, and I can open this OpenDAP URL directly, right? So let me go back here. I'm actually going to choose the one, and I know this is really tiny, but I'm going to choose the one that was modeled from the year 2000 to 2012, which is down here. Let me copy that, copy link, and I'm gonna stick it in here. So you can see that I can open this link directly, I think. Oops, I did not run this, that's why. Okay. All right, so I can open this netcdf file directly using Xray, right? Because it's using OpenDep to open it. So the one thing I want to do is try to convert this to ZAR. I want to convert this to ZAR so that I can actually dump it onto my Google Cloud storage. But before I do that, let's backtrack a little bit and show you what you can actually do on the cloud. So with Google Cloud, there is something called gsutil. It's a command line interface to actually talk to Google Cloud. Right here. Right, and I say, okay, with gsutil, I want to talk to Google Cloud, and I want to create a bucket. So I'll go to gsutil, and I'll say something like make bucket, and I want to give it my project name, which is Oceanhackweek. Right, and I want to say, okay, let's make OHW ZAR. Okay. So I'll throw you an error, and I'll say this. Right, so I've created a bucket. If I go back to my account right here, and I go back right here, and back again, I created a bucket. So it shows up there, right? So I never have to actually log onto the console. I can actually use a lot of the command line interface on my computer. So I've created a bucket right there. This is what I want to do. I want to create a bucket on the cloud that I can link to my work on Pangea. Okay. So if we go back here, I'm going to use my cheat notebook. And I'm going to say that I want to, so I looked at that, and over here as well. Okay, I did that. And then I want to do a command, something like this. So for D, I want to fill in the missing values for that file right here. Right, and we'll run that. Yes, it's not defined. Why is that? There. Okay, so the problem was that there was both missing value and fill value, and I wanted to just give it 1. And then the next thing I would do would probably be to convert this to ZAR. Let's skip that. So here, right, I'm going to stick that in there in my new notebook here. And it says that the Google Cloud storage, so I use GCFS, which is mounting that Google Cloud storage that I created as a file service. And I'm going to say that this is the one. And then the next thing I'm going to do is to list my buckets, right? So I'm going to say, I'm going to GCSLS this bucket right here. And you'll see that this matches exactly what I had in this bucket right here. So my data set, and then I had the netcdf right there. Right? Yes.
In the command line too.
You could have done that in a command line. You can do that in Python. You can do that in command line. Thank you for pointing that out. So there are ways for you to really connect to your storage on the cloud, right? So if I had done something like this, so this is actually the terminal that's on my computer that I've installed this Google Cloud command line interface. I would do something like gsutil ls. And it would give me my buckets that I've created, right? And if I say gsutil ls / OHW example, it will also just list out the stuff that I have in there. So you can see that this is exactly the same as through the Python package. Just here. Okay, which is the same as this. Okay, and then the next thing I want to do is to convert stuff to Xar.
Can you like change directories?
Yes, you can change directories. Where? Within the,
Like if you wanted to go into oh, from here, how do you get to different directories?
so what this does is you can't get into different directories. You can write it to a different directory, right? So you can't actually, so for example, in the Jupyter Notebook, you can't actually CD. So this is actually the Jupyter Notebook on Pangea. And I wanted to write the file that I created, right? The DS file that I opened initially, I wanted to write it to Xar. So I would say, okay, please write this data set, the NetCDF data set, this data set that I opened as DS. I want to write it to the bucket, OHW example, and I want it to give it a Xar store name. So let's say, for example, I want to call it CMIP6 test, right? Okay.
Sorry, could you remind me what's GCS again?
Google Cloud Storage is here. It's defined here. Okay. I'm going to give this a few minutes. Okay, all right. I got a thumbs up from Felipe, so I'm going to go on. Okay, and I'm going to click play and whoops. Forbidden. Okay, so can anyone tell me why it's forbidden? So I got a bunch of errors. I said, it said forbidden. The bucket did not have sufficient permission for me to actually create anything on it, right? So if you are using a public data set bucket and you're trying to write stuff to it, it won't allow you to because it needs some kind of verification. It needs you to provide it with some kind of authentication. And that's how you can actually kind of manage a lot of the security protocols. Because if you see this, I actually made this bucket public, but I can't actually write to it because I don't have sufficient permissions. So for those of you thinking about private data, these are one of those things that the cloud providers have actually put in place for you to be able to control access. And so the way around it, I think, is to I have no idea. Actually, you know what? I apologize. I'm actually going to use my cheat notebook because I'm so confused right now. I'm going to go back and use my cheat notebook. And I'm going to restart the entire kernel and clear all outputs. Okay, so here we go. Again, import Xray, right? I'm going to open that data set. And it's giving me some kind of error. So I want to figure out what the error is. So I'm going to do ds info. And then I'm going to convert all the missing values. And I am going to say, look, I'm going to skip this because I don't want to actually write to Xar on my local drive. So I'm going to say, okay, I want to point my Google Cloud Storage to the project that's Oceanhackweek. So, and I want to list what's in that bucket, OHW example. And I want to say, you know, I want to create this Xray data store. And it's giving me an error. Why is that? Oh, good grief. I promised you it did work just now. And that's why I never do live demos. So just take my word for this, okay? It worked just now, and I'm going to make it work. But so here, I'm just going to walk through what the code actually is doing. It's saying, write that data set that I opened to Xar. And this is giving it the path to the bucket. And it's saying, please create this. And yes.
Do you actually have the
Yeah, maybe change it.
Okay, we can try that. But that's actually the name of the Xray data store. So it's supposed to create test 555. Let's try to give it another name. Sim 6555. Okay, here we go. No. Okay, but take my word for it that it actually works. I will figure this out. But still, yes.
You run the token anonymous that second.
Anon, I suppose. Okay, by the way, I wanted to point out that if you ever run into problems and you're embarrassed, talk to Don. That's Don. He is the czar master. He is like the person that I go to, and he has really helped me with this, getting this to work. So anyway, okay, so Dodd's pointing out that let's do the token as.
Should have the lines ready.
Oh, okay. Right down here? Okay, let's see. Oh.
That's an authentication.
Yes, that is authentication, and I'm still freaking out. Okay, but regardless, take my word for it, that you would write that to Czar and you would upload it to the Google Cloud Storage, and you can do this all from the Pythonic interface, right? So if you want to think about using this for your own, I see some eye rolls, I'm sorry. I really am sorry. But if you wanted to think about using data that you have or data from somewhere that you've downloaded, this would be the way to do it. You could also do it through the command line. You could use gsutil and you could put data on to the cloud. And it works the same way, whether or not you're using Google Cloud or you're using Amazon. Basically, the methodology is the same. So instead of using something like GCS, you would use something like S3 instead. Yeah, so those are the few things I wanted to point out. And I don't know if those, okay, in the meantime, do you have any questions for me?
I have two questions. One is real simple. The piece of code that you used to replace the value thing in the beginning.
Yes.
Was that kind of a necessary step for make the conversion to Czar?
Yes.
Like what?
Yes, and this brings back to the point that if your netcdf file is not following certain conventions, it will freak out.
Is there a way to find which convention, like how your netcdf should look like?
How the, what actually looks like, sorry?
Like how the netcdf should look like in order to make this successful?
Okay, so the reason why I had to do that step was because when I did ds to czar, it said you had both values and missing values, and there was something else there. It's like invisible, not invisible, but something about like two values that were the same, missing fields, I think. And so it did a conversion to take out one of them.
Yeah. The other question is that how you would go about, let's say, for example, let's say I'm looking at the MIT ECM 2-kilometer run inside of Pangea, and then I do some sort of calculation and I have an output, but that's like still a big array, but it's a subset of like a large run. But I don't want to repeat that calculation over every time. Is that how it would go about?
Yes, you would store it. So when you do an Xray calculation, it stores everything in memory, right? So you have to write it to another netcdf, or you have to write it to a Czar format.
So can it go straight from like an Xray object to Czar without you having to say this netcdf?
Yes, it goes straight. So here is what it does is actually I opened that netcdf and stored it in DS, and then I converted it straight to Czar. Sorry, yes.
So there's like the Amazon public data set collection. And I go there and it shows these S3 buckets. And then that's pretty much where I stop. So if I import the Amazon version of this, I can just give it that S3 bucket and sort of explore it from right here.
Yes. So if you, for example, like Landsat, right? So the bucket for Landsat would be S3://Landsat-PDS. And if you just give it that, obviously within that Landsat bucket, there is a whole bunch of other files. So let me just pull that up really quickly. So if you work with Landsat data, this is what it actually looks like, right? And there's actually a whole bunch of all these little folders that are nested under the S3 bucket. So if you want to link to a specific file, you actually really have to just give it very specific, the specific URL or the specific path to the S3 location of that file. Does that make sense?
Yeah, but I don't know that.
Yes, so this is difficult. So that's why we have things like NASA CMR that's coming in, right? Yes, it's cataloging process. So again, while a lot of all these data sets are on the cloud, actually trying to access them is really difficult because they don't have a good cataloging mechanism. So again, you know, it goes back to the thing of you know, Pangea and trying to get the cloud providers to take on more of this effort of cataloging and putting data in the cloud and making access easy, but we're not there yet. So if you don't need to use the cloud or you think the cloud is an impedance, that's okay because we're still a ways behind. Yes?
It's kind of a follow-up question. So imagine I'm a PI and I have tons of data. Actually, I don't have the data yet, but I will have it some point. And then eventually I want to get that data to the cloud. What are like the steps that I should take into consideration before we're actually collecting my data and having that data in the proper NetSDF format in such a way that this process of going Xray to SAR is sort of straightforward?
So let me just rephrase the question so that I can actually process it in my mind. So you're saying that if you were a PI and you're thinking about putting your data in the cloud, what are the key components that you have to think about before doing that? I would say that, first of all, you have to think about, where are you going to store it, right? Is it AWS or is it Google? Obviously, you know, we want to move to a system where it's cloud agnostic, where, you know, it doesn't matter which cloud it's on. We're not quite there yet. So first thing is funding. Where do your funders want you to put them, right? So like for a lot of the NSF, they have like grants with Google. If they stipulate like, okay, this is a Google funded project, we're giving you credits on Google, put it in Google. So that's the first thing. Second thing is to think about like who your audience is, right? Are these people that are going to be very cloud savvy? Are they going to be people that, you know, will want to use Pangea as a platform? Or are they really just more traditional scientists that are happy with OpenDAV? So if you think about it in those terms, obviously we all want to change the paradigm. We want people to start moving their compute to the cloud, but we're still a ways away. So you want to think about like, maybe for now it's sufficient for me to store my data as NetCDF. Maybe I don't have to deal with SAR, right? Because it takes a lot of manpower for people to do that. And a lot of times researchers don't factor in that technical component. They're like, I want to do all these great things. I want to do all this great science, but you have to pay for someone to do it. You have to have that time to do it. You can't expect PhD students to do it because PhD students want to get their research done really fast. They're not going to dive into the metadata. They're not going to tell you, well, you know, I wrote this code, it didn't work, it turned in this format, and then, you know, another 20 files later, it's another format, right? So we have to start thinking about all these things. I don't know if that helps answer your question. Anyone else? I feel like I'm being a bit grumpy, but yes.
So I see the Xray throw these errors when files aren't quite CF compliant far too often. And like I know, for example, like the CNIP data is part of the GWEX, which has the IWS, which has like, you know, pages and white papers all on a data format. So if they're not getting something right, what's the method? Like do we just keep all fixing? Like, how do we do a better job communicating with the data providers when things aren't working quite right?
Oh, yes, Felipe can answer that. I think we all have very strong thoughts.
That complaint is not really about CF. It's something different because the metadata in SAR is simpler. And Xray actually is not CF strict at all. Like if you try Iris, which is an Xray alternative, it's very strict. If your data is not CF, it won't load. The problem is Xray started with an XDF model, the NUG, which is a very simple basic metadata that it's required to be an XDF file. And then they drift away from it to be a generic for the 3D plus pandas alternative. The problem is because it started with this community and it started following the NUG, now we need this workaround for that metadata. But it's the NUG actually. So we have the decode for time. We have to keep track of some of those variables. It's actually quite annoying. And the solution is to build layers on top of that. So we can actually have CF Xray and Xray. And we need compliance checkers. We're actually going to have a lightning talk because the Michael just put it in there. And the compliance checker is the way to go. So you just run it on your data set. It's compliant, great, you can go. The thing is, compliance checker doesn't really have a SAR component at the moment. But that will probably change. Can I answer your question?
You just make sure everybody goes compliant.
Yes, there is a check for that, actually. There is a check for that. Although those kind of checks are the hardest because usually if we only check metadata, we're okay. But to check something like that, we need to check the data. Compliance checking the data when the data is big, we have a problem, right? Although that's coordinates, and usually coordinates are loaded. They're not lazy loaded, unless it's a level for models that's varies in X, Y, Z, and T. But that may pose a problem in the future. So it's not that easy.
And can I just add to that really quickly? Something that I think we should all think about as part of attending Oceanhackweek is that we want to evangelize that, right? We know how hard it is for us to work with data that is not formatted correctly. And you here really have the power to change that by bringing that knowledge back to your collaborators, to your faculty advisors, to your students, that you know what to do and you should teach them. So this is where the change comes from, right? This is more of a systemic change than a compliance checker, which is great, but if your data is wrong to begin with, it's going to be wrong. It doesn't matter how much you check it, right? Yeah. So yes.
So in terms of storage, I mean, correct me if I'm wrong, but I think you're talking about like a data set that you put up there permanently, or at least somewhat permanently, right? In terms of that data is not going to be constantly modified. That's stored as an object in a bucket, right?
Yeah. So there's actually yes, you don't want to modify the data very often. So even with object storage itself, there are different levels of storage solutions. So if you've heard of something called cold storage, right? It's for data that you never want to change. You never ever want to touch it ever again. It's archival. And then for nearline, or something called, I don't know if hot storage is even a word or not, but it's something that you actually can modify. You just don't want to read and write from that object store. You can actually say, okay, I've created a whole new bunch of netcdf files. They're all new. I've checked them, and now I want to delete the old ones and upload them. The new ones, that's fine. You just don't want to do a lot of intensive reading and writing, input and output.
So then what happens if for like working level data? So, you know, if I'm working on imagery data or something, I do some processing, I want to store temporary files that I'm going to come back to continue working on. Is that through the same file system, or would that be done a different way?
So there's a cheap answer to that. So one of the things that the Xar folks or the people at GASC are trying to do is to actually allow you to mount object storage as a file system. So you can actually do that read and write. In my opinion, it doesn't work as well as if you have that image, like if you're working with TIFF images, like on your own computer, on that storage disk that is stored on your computer. So on the cloud, you have something called virtual machines that act as a computer, right? And you can attach large amounts of file systems to it. They call it block storage. And you would store that image on the block storage. You would do a lot of processing, input, output. And then once you're done with that, the architecture is really to kick it back to object store so that you're actually not incurring a lot of cost. I guess I didn't really touch on this, but this might be kind of a good subject right here to segue into, is that when you work on the cloud, you really want to think about costs. You want to optimize. The whole point of working in the cloud is so that you can optimize the cost. So for object storage, it's about 2 cents per gigabyte per month of storage. And if you're actually storing a lot of those things on that disk that's attached to your virtual image, it's about 10 cents per gigabyte per month. So you can see right there, that's a huge cost associated with that, right? If you're storing all this data that's on a disk that's attached to your virtual machine. Yes.
And it's that cost, I mean, you mentioned month, but if that's something you're doing like within an hour, like, right, you're gonna output these files, you have to save them just for a little bit and then do something else. Would you put it on the virtual machine too? Or?
I think it just depends on the case. So again, like if you're doing a lot of reading and writing, and the way the cloud actually calculates the cost is it doesn't care if you're putting, so let's say you have a virtual machine, right, that has a 1 terabyte data drive. It's not going to care if you only have 1 gigabyte of files on it. It's not going to care if you have 100 megabytes of files on it. It's going to charge you for that 1 terabyte. And so the moment that you feel like you're not going to need to work with that file anymore, the best thing is to put it on Object Store. You can always re-download or re-put that file into your local drive. Does anyone else have any more questions? I will put a working notebook up on this. Yes. Okay, great.
Let's
Okay,
take a
thanks.
minute.
Okay.